So you're probably wondering what that is. It's a box with whiskers. And that's what it's supposed to be. And I suppose you could add in some facial features, but it's definitely a box with whiskers. And that is exactly what it's supposed to be, and you'll see why here in a second. So today we are actually talking about something called box and whisker plots, and it's the last type of data display we're going to talk about in this chapter, so here we go. Alright, so this is a box and whisker plot right there, and we call it a box and whisker plot because these are our whiskers, and this is our box, which really looks like two boxes because there's some separation there. Okay, so what is it? Well, it represents data, okay, along a number line. And I didn't put any numbers down here right now, this is just an example, but normally there would be numbers here, okay, and it's drawn by using the least value, the greatest value, and the three quartiles of some data set, right? So we got like a list of numbers there, we know how to find least, greatest, and the three quartiles, and that's actually what we use to draw the box. And it's just another plot that shows us how data varies. Okay, where is the data? Is it really heavy on one end? Is it skewed? Is it not skewed? Is it symmetrical? So yeah, that's really what all this is about. So that's the least value, okay, in your data set, and then this would be your first quartile. Okay, now what we know is that in between here, 1/4 or 1/4 of all the data from our table or our list is going to fall right there. Now it doesn't exactly tell us if it's there. We know there's one at the least value, but maybe the rest of it is like there and there and there and there and there. Could be in that first quarter, or it could be a little more spread out like that. We don't know, but we do know that 1/4 of the data from whatever table we're getting it from or lists we're getting it from is right there. Now, between the quartile 1 and the quartile 2, which again we call the what? Median. Guess what? There's another 1/4 of our data, and you're probably seeing a pattern here. Between quartile 2 and quartile 3, to finish the box, there's also 1/4 of our data, approximately. It depends on if your list has an even or odd number of data, but it's close. And then the greatest value between the quartile 3 and the greatest value you see in your data set, which sometimes might be an outlier, sometimes not, there's another 1/4. And what you probably are noticing is that if I have 4/4 or 4/4, that is one whole, otherwise known as all the data, okay, is showing up in our box and whisker plot. So you might be saying, well, how in the world could you have 1/4 of the data here in this bigger part of the box, but 1/4 of the data here in the smaller part of the box? Well, so let's say there was 1, 2, 3, and 4 pieces of data there. That's fine. We would also have 4 here, but they would just be a little more concentrated, right? 1, 2, 3, 4, like that. So we're going to get more into this, but that's what a box and whisker plot looks like. Here we go. Alright, so the following data shows the number of bananas eaten on May 1st by the monkeys at Park City Zoo. Create a box and whisker plot to display the data. So just to be sure, when we're looking at this table, one monkey ate 7 bananas, another one ate 2, another one ate 6 on that day, on that same day, a different monkey ate 10. You get the idea, alright? Okay, so the things we need: least value, greatest value, quartiles 1, 2, and 3. So we can just look up here, right, and get that. Well, we could get some of it. I can get the least value, right, because I can look at that list and say, what's the smallest number? It's 2. What's the biggest number? It's 20. But for quartiles, we're going to have to do what? Put it in numerical order. So take a second and order it in a line. I'm going to put mine right there, and let's see if we get the same answer. Alright, so that's what I got. Counted up, I have 9 pieces of data there. There were 9 from the table, so looking good. Alright, so I like to do quartile 2 first, because it's the median, it's the middle, it's easiest to find. So, not the median, not the median, not the median, not the median. Oh, this one's nice, because it's an odd number of pieces of data. That right there is our quartile 2, so 10, okay? Quartile 2. Now, and again, I'm not drawing a box and whisker plot here. We're not doing that yet. Okay, quartile 1, remember, is the middle of the middle half. So here's our middle half. There's 4 values, right? 1, 2, and 3, and 4. So it's going to be right there in between 6 and 7. So quartile 1 is going to be 6.5, or you could say 6.5. Quartile 3, the middle of the upper half, and here's our upper half. So what is the middle of those right there? It's going to be right there between 14 and 16. The average of 14 and 18, my apologies. The average of 14 and 18 is 16. Okay, so we have everything we need. Now we can draw our box and whisker plot. Now, the first thing to do when drawing these box and whisker plots is to ask, okay, what's the smallest I'm going to have to go? What's the largest I'm going to have to go? Okay, and when we do that, pardon me, what we find is that I'm going to have to go from 2 up to 20. So I need to make sure I have enough room. So I probably shouldn't start right there at 2 because I'm probably not going to be able to get up to 20 if I do there. I'm sorry, 2. Probably not a good idea, right? Okay, so I'm going to just kind of start down here in that first line with 2, the smallest value I need. And then let's do some counting. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is going to get me my greatest. Alright, so we remember that in a box and whisker plot we're going to have a whisker here, 2 boxes, or a 1 box created with a line kind of splitting it, and then another whisker, right? Let's reference our photo right there, okay? So let's get this first whisker taken care of. So I need the least value in the first quartile graph, so let's do that. The least value we said was 2, okay? And we already have that marked there, so let's do that. And then quartile 1 is 6.5, so if that's 2, and we're going by ones, then I probably better count out by 1. So 3, 4, 5, 6, and that's 7, so our first quartile is going to be right there. And so our whisker is going to look like that, okay? But remember, the first quartile starts the box, okay? So now we're going to need, let's do this first, or this first part of our box. We need quartile 1, which we already have, and quartile 2. Okay, so quartile 2 is 10, so that's 7, 8, 9, 10 is right there, 7, 8, 9, 10. And that's going to split our box, so now we can do that. And then next we're going to need quartile 3, which was 16, so 10, 11, 12, 13, 14, 15, 16 is right there. Come and draw a line there. You can start with a dot and then draw a line, whatever you want. Okay, and then lastly, we know already graphed our greatest value, and that's going to be denoted by a dot, and that dot goes from the box, pardon me, to the box, and creates our last whisker. So there you go. You just created a box and whisker plot. And remember that about a quarter of our data lies right there. So if we look back at our data list, we had 9 values, right? So to find 1/4 or a quarter of 9, you know, our answer is not going to be approximate. But let's think what values would be in between 2 and 6 from our table, including those values. So we had 2, right? And then we had 6, and then 8, not quite, okay? So 2 isn't quite a fourth of 9. And again, this is why we don't say it's exactly a fourth of our data. It's about a fourth of the data lie there. So between 6.5 and 10, we'd have, you know, 7, obviously. We'd have 8 in there, and then we'd also have 10. So that's 3 pieces of data lie right there. So that's a little more than a fourth of 9. But again, we're not talking about exact. It's approximately a fourth there, approximately a fourth, approximately a fourth, and approximately a fourth. All right, so lastly, we're going to just compare and contrast some different box and whisker plots, talking about homerooms. All right, so I made a couple of different box and whisker plots for heights of students in Mr. M's homeroom and Mr. B's homeroom. Okay, so what we can see is we got a box and whisker plot there and one there, and they look a little different. So let's do some comparing and contrasting, okay? So what fraction, and I'm going to say approximate fraction, of students in Mr. M's homeroom are 55 inches tall or less? Well, let's find 55 inches, okay, and that's actually our what? That's the quartile 2, or our median. Okay, and what fraction of students are 55 or less? Well, remember, in the first whisker, there's a fourth of the data, and then in this box, there's a fourth of the data. So there's a fourth and a fourth. What's a fourth plus a fourth? Well, that'll be 2/4, and then that simplifies to 1/2. So half the data. We could also ask what percent of the data, approximately, or what percent of students are 55 or less. We could also say, well, we know a half is 50%. That would also work. Okay. What's the height of the shortest person in Mr. M's homeroom? Well, remember, the box and whisker plot, that is going to be the min, or the minimum value, and that's our max, or our greatest value. So the shortest person would be the min, or the least value, and that's going to be 47. And we got to look down here. What are we doing? We're measuring all this in inches. Okay. What is the height of the tallest person in Mr. B's homeroom? Well, okay, again, that's going to be our greatest value. That actually comes from the data table. It's not a quartile. That's actually a value. Only these three are quartiles. This one is coming right from the table, and he must have someone who is 70 inches tall in his homeroom as the tallest person. Now, what fraction of students, approximately, in Mr. B's homeroom are between 59 and 65? Well, between 59 and 65, that's only one part of our box, and we know that a fourth is there, a fourth is there, a fourth is there, and a fourth is there. So between 59 and 65, there's only 1/4. What would that be as a percent? Well, 1/4 is the same as saying 25%. So one of the two. All right, guys, that's all I got for you. Thank you for sticking with it. I will see you in class, and we'll talk more about box and whisker plots.